So we're going to be now solving quadratic equations by factoring. Something important to know is that standard form for these is always ax squared plus bx plus c equals 0. We have done factoring before, so this isn't new. The only added new steps is that it's now equal to 0. So what you need to make sure is your first step is that you want to use addition or subtraction to make the polynomial equal to 0. You're then going to factor the polynomial. Your next step is that you're going to set each binomial or parentheses equal to 0. And then you are going to solve for each variable. So when I'm doing this, I want to make sure that I'm looking to make sure that it's equal to 0, and I also want to make sure that I can factor it to the lowest point. So for this first one, this is not in standard form. So what I'm going to do is I'm going to add the 26 over to the other side because I want to make it so that it's set equal to 0. So then I have x squared plus 15x plus 26 equals 0. I now notice that it's a trinomial. So I'm going to find the factors of my a value and find the factors of my c value. So factors of x squared are x times x. Factors of 26 are 1 and 26 and 2 and 13. I now have to say, okay, if I have my two binomials, I'm going to bring down this equals to 0. I have to get them so that if I multiply the outside and the inside, they're going to add up to 15. So what I'm going to do is I know that they have to multiply to give you a positive 26 and add up to a positive 15. So I'm going to use the plus 13 and the plus 2 because if I multiply the outside, I get 2x. If I multiply the inside, I get plus 13x. That does add up to the 15x, so I'm good to go. Now, the final step is set each binomial or parentheses equal to 0. So I'm going to take x plus 13 and set it equal to 0, and I'm going to take x plus 2 and set it equal to 0. Now, you can actually drop the parentheses if you want to, and then just solve for x. So I'm going to subtract 13 on both sides. So one of my answers is going to be x equals negative 13. And I'm going to subtract 2 from both sides, and I'm going to get x equals negative 2 and x equals negative 13. So that is my answer. Okay. Now with this one, you're going to notice that it's already set up for you. You already have your two binomials, so you can actually just set it equal to 0 and solve. You're finding your x-intercepts here, so you're finding where it's going to cross the x-axis. So what we're going to do is we're going to set each of these equal to 0. So I'm going to add 5 on both sides. So I get 4a equals 5. I'm going to divide by 4. I get a equals 5/4. That's one of my answers. My next one, I'm going to subtract 6. I get 4a equals negative 6. Divide by 4 because I want to get a by itself. So I get a equals negative 6/4. So these two are going to be my two answers. Now with this one, you notice it's not a trinomial. So I'm going to kind of look to see, you always have to remember too if you can take out a GCF. So I'm going to ask myself, can I take out a GCF? And I can here. So they both have an x in common. So what I'm going to do is I'm going to take out an x, and I have x minus 4 equals 0. I can't factor this any further. So what I'm going to do is I'm going to set my GCF equal to 0, and I'm going to set also my x minus 4 equal to 0. So my GCF x equals 0, that's one of my answers. My other one, I'm going to do x minus 4 equals 0. I'm going to add 4 to each side, and I'm going to get x equals 4. So that's my other solution. So my two solutions are x equals 0 and x equals 4. Now my next one is I'm going to say to myself, okay, is it set equal to 0? It is. So now I got to find, I'm going to see how I can factor. I notice it's a trinomial, so I'm going to factor. I'm going to find the factors of the a and the c. So here's my factors. Now with 144, there's a ton of factors. So I got to think about, okay, what's going to get me to add up to that negative 24? So if I go through my factors, I got 1 and 144. I have 2 and 72. I have 3 times 48. I have 4 times 36. I have 6 times 24. 8 times 18. 9 times 16. And 12 times 12. Now I have to look at my factors and say, okay, how can I get it so that I multiply and I multiply to 144 but add up to a negative 24? And that's going to be this 12 and 12. So I'm going to have a minus 12 and a minus 12. That's because when I multiply the outside and the inside, I'm going to get negative 12x minus 12x, and it does equal that negative 24x. So I'm good. So I'm now going to set these both equal to 0. If you notice, though, they're the same binomial, so you're actually only going to have one solution. So your solution is going to be x equals 12, and that's it. There is no other solution here. So this means that it's only going to cross that x-axis one time. So you have one x-intercept here. Now, I have to look and see, is this in standard form? And it's not. So what I'm going to do is I'm going to subtract 6 on both sides. I get 2x squared plus 21x plus 19 equals 0. I'm then going to ask myself, can I take out a GCF? And I can't. So I'm then going to find the factors of 2x times x, and then factors of 19, and that's just 1 and 19 because that's a prime value. I'm then going to set up and see, I'm going to set up my first terms in my binomials and set it equal to 0. And I'm going to say 2x times what? And something times 1. How is that going to get me 21? So I'm going to put the 1 here, and it's going to be positive, and I'm going to put the 19 here. And the reason for that is that you're going to have, that would be 2x plus 19x does equal 21x, so I'm good to go. I'm then going to set both of these equal to 0, so I have 2x plus 19 equal to 0. I'm going to solve, so I got subtract 19 on both sides. I get 2x equals negative 19. I divide by 2, and I get x equals negative 19 over 2. That's one of my answers. My other one, I'm going to put that one up here. I get x plus 1 equals 0, minus 1, minus 1. So my other solution is going to be x equals negative 1. Now, my next one, I'm going to say to myself, can I take out a GCF? And I can here. I can take out a 2. So I'm left with x squared minus 5x plus 4 equals 0. I'm then going to factor. I notice it's a trinomial, so I'm going to factor on the inside. So I have x times x, and 1 times 4, and 2 times 2. I'm going to bring down that GCF, and I'm going to set up my two binomials and set it equal to 0. So I have x and x. So I'm going to say to myself, okay, how can I get that negative 5? So I'm going to actually do a negative 4 and a negative 1. That is because if I take my outside and my inside, I'm going to get negative 4x minus 1x equals negative 5x, which is good. I'm then going to set all of these equal to 0. Now, The thing about this is that if I set my GCF equal to 0, it's not true, so it's actually not a solution. So we're not going to worry about the GCF here. If it was a 2x, you would then want to set it up, but because it can't equal 0, it's going to not be one of my solutions. So now I have x minus 1 equals 0. So I add 1, I get x equals 1. That's one of my solutions. My other one is x minus 4 equals 0. I add 4 on both sides. I get x equals 4. Okay. Now, these two are special cases, and this goes back to these are the difference of two perfect squares. And you're going to notice they're a little bit different because they don't have the b value. And so what I'm going to do is I notice that 81 and 16 are perfect squares, and there's a minus sign. That is called a difference of two perfect squares. So what actually happens is you take the square root of the 81 and the 16, the 81x squared and the 16. So I'm going to actually get 9x, I'm going to get and 4, and 9x and 4 is set equal to 0. Because it's a minus, I have to do a minus 4 and a plus 4. You're going to notice if I actually multiply the outside and the inside terms, I get 36x and I get minus 36x and it gets 0x. And that's what I got here, or just 0. I don't even want to include that. I get that 0. So I don't have a b value. So this is my correct answer. But to find out what the x values are, I'm going to set them both equal to 0. Okay, so I'm going to add 4 on both sides. I'm going to get 9x equals 4, divide by 9, and I get x equal 4/9. That's 1. I'm going to subtract 4. 9x equals negative 4, divide by 9. I get x equals negative 4/9. Now, this looks similar to what we did yesterday with the finding or solving quadratic equations with taking the square root. The thing you have to be careful about with this one is this is a perfect square value, so you want to make sure. This is also something that we taught you this part, but this is kind of new to you, so you definitely want to make sure you understand this. This is the same thing too, because you can take the perfect square of x squared and you can take the perfect square of 49. So it's going to be x minus 7 and x plus 7 equals 0. If you think about it, if I multiply the outside and the inside terms, I'm going to get 7x minus 7x, which does give me 0, so I don't have that b value, so that works. Okay, so then I'm going to set my two equations up. And I get plus 7, x equals 7, and I have minus 7. So these are my two solutions.